Take it away, baby.
RobotArms. I've heard of them, you've heard of them. You might even have one. Okay, probably not. They can do loads of things. They can lift heavy stuff. They can build heavy stuff. But what I have never seen one do is feed stuff. So, over the next month, I'm going to make one that I can control that can feed me. There's two main bits to this robotic arm. The first thing you have is you've got this computer-aided design, or CAD, of the arm. It's going to be 3D printed, and it's going to be the physical body that the real world interacts with. The second thing is the circuit, and I'm going to make an interactive circuit, meaning that I'm going to be able to turn these potentiometer dials to make the arm do what I want. In this case, feed me and bring food to my mouth. The CAD is split into three sections. You've got the base, the arms, and the gripper. The base is going to hold this big servo that's going to allow for 270-degree rotation. The arms hold these little micro servo motors which allow for loads of degrees of freedom. And the gripper is a gripper. It grips stuff. I made these two, but I got inspiration online from this guy, and I have no idea how to pronounce his name, so thanks to him. Now, with all those designed, it's just a case of 3D printing, and that's really annoying because my printer kept on breaking, and also really boring to watch. So, montage!
You donkey!
Before making up the full assembly, I quickly tested if the servos would function as I intended them to, and there was no jittering with the servos, which was very nice to see.
By combining all those little bits, I can make this. So I've got my base with the big servo in it, I've got my arms, and I've got my gripper. You can see it looks pretty flimsy, but actually when you start to move it with the circuit I tested the thing with earlier, it looks pretty good.
A few moments later.
Success!
The circuit is split up into two sections, the dial section and the button section. The dial section controls 4 servo motors. These are in the base and all the arms. They are controlled through a potentiometer. When I change the resistance in the circuit, that maps to a particular angle value on these servo motors, and it can move the arms as the user wants them. The second bit is the button part of the circuit. The user can press this button to move in the servo at the very top. This is the gripper part of the circuit. An important part of this circuit is the current sensing.
Look at the mess!
It allows for object detection. It's trying to solve that issue that we had in the hand video of how do we know when we're gripping something? Well, it's a little bit of a scaled down version in comparison to the hand video, but when I press this button, you can see it does all the thinking for itself. I don't have to do anything past this. After making a quick design change to the gripper arm, I got the arm lifting heavier items. Now I was ready to have some fun with it. So, let's see if I can grip this weird toilet roll thing with the arm. Using all my techniques. Oh yeah. Okay. Hell yeah. Hell yeah, baby. Look at that. Damn, bring it around. Damn, that's pretty cool. And then release. Huh, that almost fell out, but... Well, don't know about you guys, but after that I'm feeling pretty damn hungry, so let's go. Alright, a little bit grip.
I'll take a potato chip.
Right, take it up. Come around. Which one would be around? This one's around. Oh yeah, baby. And then...
And eat it.
That was pretty cool, but not cool enough. Buttons are boring, so let's make it finger controlled.
What is that?
This is the GFT, or glove finger thing for short. It's an exoskeleton that sits around my index finger that has a force-sensitive resistor running through it, which is a piezo-resistive transducer, or for those of you with a social life, can change its resistance in an electrical circuit when stuff happens. Before we can talk about the force-sensitive resistor, we got to talk about this exoskeleton. Just like before, I made it in CAD and then I 3D printed it. And this time I actually collected videos for it. So, montage! With that 3D printed, I could assemble the exoskeleton. I was running this shock cord through the back of it so that I could get this really springy nature, and that's how fast I was doing it, by the way. I really am that fast. The force-sensitive resistor, or FSR, is controlled using this circuit, which was incredibly hard to build. I set up some code to get a reading for how the FSR was interacting with its current environment. When I close my finger, I contact the FSR, and that creates a spike in the measurement. Although that's a scale between 0 and 1023, this FSR was super sensitive, so I'm essentially just going to treat it like an on and off switch. By switching out the button code with the GFT code, I'm able to move the gripper now using only my finger. So that's closed, and that's open. Oh man, a waffle cone. I love waffle cones. If only I had a RoboticArm and a GFT to help me grip this thing. It's so far away from me. Oh, I do have a GFT and a RoboticArm. Therefore, rotate it a bit. It's a bit too far. Okay. Down. Grip. Alright. Other way. Okay. Now rotate it to my mouth. I'm up here. Ah. Yeah. Well, that's the video. If you enjoyed, sub. It gives me self-gratification.